All right, today we continue our lesson on simplifying rational expressions, but now we expand it beyond just one fraction. In this case, we go now to multiplying and dividing fractions. And again, we're going to start off with two examples that are examples of fractions that you've multiplied or you divided in your lifetime up until this point that have no variables whatsoever, because the same concepts that apply here to multiplying and dividing fractions is the same thing that applies when we add in some expressions and some variables. All right, so we got to make sure that we understand the base concept first. Let's take a look at simplifying these two questions here. Let's start with number one. When I ask you to multiply 2/3 times 9/14, all right, many of you would simply just do top times top, bottom times bottom, and you would say, oh, 2 times 9, that's 18 over 3 times 14. Some of you would get out your calculators or not, but you'd say 42. All right, and then at that point, you would then go, okay, how can I simplify this? Can I make it a little bit smaller? What number goes into both 18 and 42? And you'd go, 6. All right, so we'd say, okay, that's 6 times 3, and that's 6 times 7, and therefore the 6's cancel out as we saw yesterday, and we get 3 over 7. All right, so at that point, it reduces down to 3/7. But some of you might look at the original problem and go, there's an easier way. You don't have to multiply top times top first. What if instead you looked for the giant ones first? You identified a number on both top and bottom in either fraction that could help you reduce this before we even begin. And that's what I want to encourage you to do here. So I'm just going to do this down this next line down here. What if on top I said, well, it's 2 times 9, but 9 can be rewritten as 3 times 3, right? And on bottom I've got 3 times 14, but 14 can be rewritten as 2 times 7. What do we notice right away? Well, I see that I've got the same numbers on both top and bottom. I've got this 2 times 3 on top and this 2 times 3 on the bottom. Both of those are 6. All right, give me a giant 1. You could rewrite it as 2 times 3 times 3 over 2 times 3 times 7. Multiplication's commutative if you want to see each of those giant ones separately. But essentially, we're noticing a common factor on top and bottom that will end up canceling each other out. What's left over when we do that? Well, this gives us a giant 1, and 1 times 3 is 3 over 1 times 7 is 7. Notice we get the same result either way. That's what I want to encourage you to do. I want to encourage you to cancel things out prior to multiplying, because when we throw variables in, you won't be able to multiply completely first. We want to look to cancel before we do that. What about division? If you remember, a lot of you have kind of gone away from this process of dividing fractions because you're like, hey guys, I have a calculator. Let me just go ahead and plug that into my calculator. Well, yeah, that's possible. But if you recall, before you were allowed to use a calculator when dividing fractions, you actually had to change this. You had to change a division problem into multiplying by the reciprocal. We took something like 3/5 divided by 12/25, and we changed it to 3/5. We kept the first fraction, changed that division to multiplication, and we flipped our second fraction. The reciprocal of 12/25 is 25/12. Now we have a multiplication problem, and I can do exactly what we did before. We can look at 3 over 5 times, and we can factor out these numbers to get ourselves some nice factors that we could see that could cancel. All right, and then when I see that, I see I've got a 3 on top, 3 on bottom, 5 on bottom, 5 on top, and therefore this entire thing simplifies down to 5/4. All right, with no need to reduce further because we already took out the common factors on both top and bottom. That's multiplying and dividing fractions and simplifying them as you know it. Now let's move in to adding in some variables. All right, let's take a look at 1015 here. In 1015, they don't have you factor yet. They've already factored everything for us. We've just got groups. I know that everything's factored because I don't see a variable that is squared. Let's look at A. In A, I've got 4 plus 3 over x minus 5 times x minus 5 over x plus 3. Well, if you recall from yesterday, if I've got something on top and bottom that's the same, I can cancel it if it's a number, if it's a variable, or even if it's an entire group. And that's what I see here. I've got an x minus 5 here and an x minus 5 here. Those will make a giant 1. It doesn't matter that one's in one fraction, one's the other, as long as one's on top, one's on bottom. When I do that, I cancel them and I get a 1. and there's nothing else I can cancel. I can't cancel these 3's. You might be tempted to, but they are inside our parentheses. You can't get to them. And if you look at the groups, they're not the same group. It's a 4x plus 3 and only an x plus 3. That's not the same number. So what's left on top? Well, I'm left with 4x plus 3 over x plus 3. But don't forget, we have one more step to do when we have a variable involved, and that is to state our values of x that are not allowed. This will be true as long as x does not equal anything that would make a denominator 0. In this case, I've got 2 groups in my denominator that could end up being 0 if x is a certain number. I need to look at both of them, all denominators across the board here. So in this case, what value of x would make x minus 5 equal to 0? Well, that is 5, so x can't be 5. What value of x would make x plus 3 equal to 0? Well, that is negative 3, so x is not allowed to be negative 3. So this expression will always simplify down to 4x plus 3 over x plus 3 as long as x does not equal 5 or negative 3. Let's look at B. We've got a division problem now. We saw this last time, right? Instead of dividing, we're going to multiply. So let's rewrite this. X plus 2 over 9x plus minus 1. First fraction does not change, but division becomes multiplication, and we flip my second fraction, all right, giving me the reciprocal. And notice what happens at this point. I've got some groups. And do you notice any groups the same on top and bottom? Well, yeah, 9x minus 1, 9x minus 1, same on top and bottom. And nothing else can cancel there. Those give me 1s. So left on top, I've got x plus 2 over 2x plus 1. And that will always be true as long as x does not equal. Let's look at the values that would make x 0. And let's look at our first denominator here. This one right here, 9x minus 1. Well, if 9x minus 1 were set equal to 0, then x would have to be... look at that. X would have to be 1/9. Therefore, x cannot be 1/9 because I did not want it to be equal to 0. All right. So in this case, x cannot be 1/9. And I would encourage you at this point to start looking at a way to shortcut that. All right. I noticed that every single time I have a group like this and I'm setting it equal to 0, it always seems to be the opposite of the constant divided by x's coefficient. What I mean by that is this, and I'm going to give you a different color here. If I've got a denominator, let's say I have ax plus b. Well, if I don't want that to equal 0, all right, well then, if I subtract b from each side, I get ax cannot equal negative b, and then I divide by a. I find that x cannot equal the opposite of the constant b divided by the coefficient of xa. All right, that always seems to be the case. Let's use that on this next one to make this process a little simpler. Let's look at our second group here. X cannot be a value that would make 2x plus 1 equal to 0. Well, what's the opposite of the constant? The constant's plus 1, so negative 1, divided by my coefficient of x, 2, divided by 2. So x cannot be negative 1/2. All right, and that would be my answer there for B. All right, let's do C. See, it's already multiplication. Great. I don't need to factor. There's no x squared, or in this case, m squared. I do see they're trying to mess with me. I've got a 2m plus 3 and a 3 plus 2m, but remember, addition is commutative, so I could see that as a 2m plus 3, and therefore, they will cancel each other out and leave me with a 1 in its place, leaving me with 7 plus 4m on top. I'm going to rewrite that. I like my variables to come first, so 4m plus 7. Over 3m minus 2. In this case, it's 4m cannot equal. And let's look at our denominators. Well, right here, what's the opposite of the constant? Well, it's minus 2, so it's going to be plus 2. Divided by the coefficient of m, 3. So m cannot be 2/3. And then look at this one over here. What's the opposite of the constant? Well, it's a 3 there, so it's going to be a negative 3 divided by the coefficient of m is 2. So m cannot be 2/3, nor can it be negative 3/2, and that's our result right there. What I want you to do right now is I'd like you to go ahead and pause this video. I want you to now try and complete 1015 D, E, and F on your own. All right, so pause this video, try to do it on your own, then pick this video back up again. At this point, I assume that you've already paused the video, you've already tried to do D, E, and F on your own, and now let's check your answers, see how you're doing, see if you got it right. Let's go over D first. In D, I've got a unique situation here. I've got y minus 2 cubed. That means there's 3 y minus 2's up top. All right, you could think of this as a y minus 2 times a y minus 2 times a y minus 2. All right, that's all up top right there. That's what cubed means. All right, I've got this 3m on the bottom. I've got a group of y plus 5 up top. Let's cancel what we have. Well, the only thing I see that's the same on top and bottom is this y minus 2 down here and a y minus 2 up top. Well, if I remove one of those, because 1 for 1, I'm left with 2. A way I can do that is to just cross off this 3 and put a 2 in its place because I took one of those y minus 2's out. That's how I do it. All right, and that would leave me with y minus 2 squared times y plus 5 on top. Over on the bottom here, I've got 3y times y plus 2. For the sake of time, I'm not going to have you multiply all of that back out again. Technically, we really should if we want to simplify everything back out, but I'm not going to have you do that in this case here. But we will state our excluded values of y. For y cannot equal, and let's look where y was in our denominator. All right, well, our first one that we see here, the first y in our denominator is right here. We've got y just down there with a 3. Well, what times 3 is 0? Well, 3 times 0 is 0, so y can't be 0. All right, I see I've got a y here, y plus 2. Well, what value of y would make that 0? Well, the opposite would be negative 2, so y can't be negative 2. I've got this one here, y minus 2, and therefore y can't be positive 2. And that's everywhere that I've got a y in my denominator. So that would be my final expression. Let's take a look at E. In E, I've got division here, so I got to start off by changing that. 15x cubed over 3y times 4y squared over 10x squared y. All right, so in this case here, I've got some things I can look at. Let's look at my numbers first. Let's break everything apart here. Let's look at just my numbers. Up here, I've got 15. Well, that 15, I'm going to rewrite that. That is a 3 times 5 times, and I've got x squared. Over on the bottom, I've got a 3 times 1 times y. On the other side, I've got a 4. That could go down to a 2 and a 2 times y squared. I'm going to say y times y. You'll see y in a moment. Y. All right, and then down here, I've got a 5 times 2, and I've got an x squared and a y. And now let's look at everything that can cancel out here. Well, this is quite a bit. I've got a 3 with a 3, 5 with a 5, x squared with an x squared, 2 with a 2, y with a y, and y with a y. There's a lot that canceled out. Remember, anything time it cancels out, it leaves me with a 1. So all up top there, I've got 1 times 2. That's the 1, 2 that didn't get out there, 2. And on the bottom there, I've got 1 times 1 on the bottom, so 2 over 1. Therefore, this whole thing goes down to 1. As long as y and x does not equal a few things. So let's take it here. For x cannot equal, and in this case, I also have a y cannot equal. All right, and let's look at what we got. Well, let's look at our denominator. What value of y would make my denominator 0 here? And so in this case, I've got 3 times y, so 3 times 0, so y can't be 0. Down there, x squared, what would make that 0? Well, 0 squared is 0, so x can't be 0. This y, I see, again, it can't be 0. And there's another place that I really have to look. And it hasn't really come into play yet. We didn't really pay attention to it over here in B because things were already canceled out and this 9x and 9x were the same. But there's another place that was in the denominator initially, and that's this right here, all right, which is now up top when we flipped it. But in this case, it's still 0. It's going to be the same thing there, all right, because 0 is what would make all of these denominators 0. All right, so this one would reduce down to 1, provided x is not 0 and y is not 0. All right, let's take a look at F. We are doing division, so once again, let's go ahead and we are going to rewrite this. I'm going to cheat here. Watch this. Oh, look at that. Oh, quick job. You couldn't do that on your paper. Sucks for you, but that's okay. All right, and then I'm going to take this here, and let's copy that straight down on top, and this up here, and we will copy that straight down on bottom there. All right, so I've rewritten it, changed my division to multiplication, and flipped my second fraction, my numerator, before my denominator got the reciprocal. Now everything's factored. Let's take a look at our groups. Let's cancel out 5x minus 2, 5x minus 2. I've got an x minus 4, an x minus 4. I've got a 2x minus 3, and I've got 2 of them down here. It's going to cancel so that there's only 1 left. Be careful with that. That gives me a final result. Up top, I've got 3x plus 1. Over on the bottom, I've got 2x minus 3. And that is going to be what it simplifies down to, as long as x does not equal some values. And let's take a look at our denominators. All right, first off right here in my denominator, the opposite, I want to see what makes it 0. So the opposite of minus 3 is positive 3 divided by the coefficient of x, 2. All right, let's look at this one here. The opposite of minus 2 is positive 2 divided by the coefficient of x, which is 5. Let's look right here. The opposite of minus 4 is positive 4. And I got to go back. The original denominator was also here. Again, that's this one up top now. So when I'm dividing, I've got to look in 3 spots. All right, and let's take a look here. If you notice, I did 2x minus 3 already, and I actually did x minus 4 already. Those are already included in our values down here. So sometimes I don't really need to consider that. I should always look. I should always consider it, but sometimes I won't need to add those values because I already have them. All right, so in this case here, it would simplify down to 3x plus 1 over 2x minus 3, as long as x does not equal 3 halves, 2 fifths, or 4. All right, so with all that in mind, let's now put it all together. Let's take a look at this here. Let's look at our steps. These are the official steps now. Step number 1, change your multiplication to division. All right, change your multiplication to division. Go ahead and do that in 16. Try and do that now. Try to follow all these steps for A and B. All right, change your multiplication to division. Then factor the expressions on top and bottom. Split them up into the numbers that you can cancel. Remove any giant ones. Simplify what remains and state the excluded values of x. Do A and B first. Go ahead and pause this video. All right. Now, I assume you paused the video, you did A and B. Let's check to see how you did. First one, it is already multiplication, so I don't need to do step 1. Let's go to step 2. Factor the top and bottom. I see some things that I could break this apart into. All right, let's start splitting some things up. Let's go 4 times 5 on top there, and I'm going to go 11 times 2 times, let's go 2 times 7, and down here let's do 5 times 7. All right, let's start canceling some things. I see I got a 2 and a 2, a 5 and a 5, a 7 and a 7, and I'm left with 4 over 11. No excluded values because there's no variable. Let's look at B. All right, well, let's start off. I've got 12 over 40, and I'm going to change that division to multiplication, and I'm going to change the second fraction to the reciprocal. Let's split things up. I've got 4 times 3 over 4 times 10 times, I've got 3 times 2 over 3 times 5. I've got a few things I can cancel. Let's go with my 4 and 4. I've got my 3 and 3. But I didn't see, can I cancel anything else? Oh, well, hey, what about that 10 and that 2? This is really 2 times 5, right? All right, so if I come down here and rewrite that 10 as 2 times 5, I can cancel a 2 and a 2. All right, anything else that can cancel? Now, the 5s are on the bottom together. They can't cancel. 5s are on the bottom together. Can't cancel, but up top, I have 3. And this is where I ask you, when we write the bottom here, would I write it as 5 times 5? Some of you might be wondering, why do I have to multiply things back together? Why do I have to simplify what remains? Well, that's because you wouldn't leave this as 3 over 5 times 5. We would leave this as 3 over 25. All right, and that would be my final result there. Let's take a look at another one. All right, now all of a sudden, let's put some variables in here. I'm going to do this one for you, show you how it is, and then you're going to do the rest of these in 16 and then come back and check your answers. So take a look at this one here. Step number 1, change your division to multiplication. All right, so in this case, my first one is going to stay exactly the same. All right, that's just going to stay exactly the same. My second one, however, is going to change. I'm going to rewrite this by changing my division to multiplication and then flipping my second fraction there. So multiply, flip that second fraction. Now it's in multiplication, factor everything, top and bottom. This is 4 factoring problems here. All right, I'm going to set myself up down below with my 2 lines, my multiplication between, And I'm going to start with the first one, number 1. All right, pull out a GCF. First thing I see, 5 goes into both of those, leaving me with x minus 3. There's no x squared, so I can't go further. All right, number 2 down here. I notice there's no GCF. 3 is prime, and it doesn't go into 10 nor 8. So I'm going to have to go off to the side here, and I'm going to do this in a little bit of yellow here. But off to the side, I'm going to do my little diamond problem and generic rectangle. All right, and I'm going to see 3x squared, negative 8, so that's negative 24, and adds to get 10. What multiplies to negative 24 and adds to get 10? Well, 12 and negative 2. 12x, negative 2x. I can pull out my 4. I can pull out my x. 3x, negative 2. All right, so all of that boils down to 3x minus 2 times x plus 4. If you struggle with factoring, go back and practice. You need it for this. Step 3, let's do our third one. Well, not step 3, but the third factoring problem. No GCF again. So once again, I'm going to come off to the side, and I'm going to do my little factoring work off to the side over here. All right, so my diamond problem and generic rectangle. All right, 3x squared, 4, so that's 12, negative 8. What multiplies to make that work? That's going to be a negative 6 and a negative 2. So negative 2x, 3x, negative 2. All right, so that all boils down to, it factors down to 3x minus 2 over x minus 2. And then my last one, oh, thank goodness, this one's a just x squared, so this goes down to x and x. And I just need my diamond problem in order to get that. I'm going to draw my little arrow down there. Just need my diamond problem. What multiplies to get negative 12? That looks like 72. Negative 12 over 1 there. What adds to get 1? Well, that's going to be a 4 and a negative 3. Good. So now I've got them all factored. I can put this plus 4 down here. It's minus 3. Now they're all factored. Cancel out the groups you see that are the same on top and bottom. I've got an x minus 3, x minus 3. I've got 3x minus 2, 3x minus 2. You can't cancel the x plus 4s because those are not on top and bottom. All right? So what's left on top? I'm just going to highlight this here. All right? What's left on top? I've got this 5, and I've got this x minus 2 on top. On bottom, I've got an x plus 4 and another x plus 4. All right? So if I were to simplify this down, I'm going to multiply things back together. In this case, I'm going to take that 5 and distribute it. 5 times x would give me 5x, and 5 times negative 2 is negative 10. Over on the bottom, I've got x plus 4 times x plus 4. All right, if I multiply that back out, I get myself an x squared plus 8x plus 16. It's a perfect square trinomial. And I need to state my excluded values. For x cannot equal, and look at everywhere x was in a denominator. That is here. All right, the opposite of that would be, the opposite of minus 2 is plus 2 divided by the coefficient of x. So 2/3. Here, the opposite of plus 4 is minus 4. All right. Here, the opposite of plus 4 is minus 4. Already got that one. All right. Here, the opposite of minus 3 is a positive 3. And don't forget, it was originally division. This up here was originally in my denominator, so I also have to look there. So let's take a look at each one of these. Well, I've got 3x minus 2. I already did that one, 2/3. And x minus 2, the opposite of minus 2 is a positive 2. That's all my excluded values of x. So this would be my final answer. I know that's a lot. Take a breather right now. All right, take a breather, and then tackle D, E, and F. All right? I would encourage you, do D, then watch this part of the video, then pause, do E, and so on. That way you're just making sure you're getting each one of these right as you go. All right, go ahead and pause it, and do D on your own. All right, let's go ahead and tackle D at this point. It's already multiplication, so that's good. We're going to factor top and bottom. I'm going to set myself up for where I'm going. And factor my top, I notice that 6 goes into both of those, leaving me with 2x minus 3. All right, there I see I've got just x squared, which is nice. All right, so I'm looking for two things that multiply to get negative 15 but add to get negative 2. That is 5 and negative 3, so x plus 5, x minus 3. On this side over here, I see I've got just x squared, which is nice. And good news is on the keystone, they'll always be just x squared ones like that. All right, sometimes they'll have a GCF, but they will always boil down to just x squared. All right, and I see that just needs to multiply to get negative 12, but add to get negative 1. So negative 4 and 3. All right, negative 4 and positive 3. If you are ever stuck, you can look at some other numbers that have been used out there to see if it helps you at all. All right, and then this one right here. Oh, I see that I've got something. First off, this goes down to 3. I pull out a GCF, 3x squared minus 3x minus 4. I pull out that GCF first, so this one goes 3. But then it's a just x squared. So again, that's one that you might see on a keystone, something like that. Once you pull out the GCF, a just x squared remains. And what multiplies here to get negative 4 but adds to get negative 3? Well, that's negative 4 and positive 1. So negative 4 and positive 1. Now everything's factored. Let's cancel what we have. I'm going to start with my numbers first. Some of you might forget about the numbers, but don't miss them. I've got a 6 and a 3 here. All right, 6 and 3. 3 goes into 3 once, and 3 goes into 6 twice. All right. I also notice 2x minus 3 doesn't have a partner. X minus 4 does, and x plus 3, x minus 3. Not a partner there, so we can't go down any further. All right, so let's simplify this out. We've got 2 times 2x minus 3 times x plus 3. All right, all over x plus 5, x minus 3, and x plus 1. All right, and we're going to multiply those back out again. I know that's a little bit taxing for some of you. Some of you might have some trouble with this, but we're going to do it anyway. Sorry. All right, so as we look at this, we're going to multiply these back out, and we're going to see that we get 4x minus 6 times x plus 3. And if I multiply each of these pieces here, all right, to get my FOIL, all right, I'm going to have up top, I get 4x squared. Then I'm going to get 12x and a negative 6x. It's going to leave me with a positive 6x. And then negative 3 times 6 is going to give me a negative 18. All right, on the bottom, we're going to multiply some things out here. All right, in this case, I'm going to start off with just these first two here. All right, that gives me an x squared plus 2x minus 15. But then we're going to take that and we're going to multiply it by x plus 1. All right, and if I multiply each of these pieces, you could get yourself a generic rectangle to do so. That's perfectly fine. All right, for those of you that need to see that, it would look like this. Let me just pull it over here. That's x squared plus 2x minus 15. And then an x plus 1. And if you did your generic rectangle, you just do each of these pieces multiplied with the others. All right, this x squared times x is x cubed, x squared, 2x squared, 2x, negative 15x, negative 15. That gives me x cubed, all right, plus 3x squared minus 13x minus 15. All right, so if I come back here, I'm going to put that right down here. I'm going to shrink it down a little bit. All right, and that would be my final result. And we have to say what x cannot be. 4x cannot be. And let's take a look at these. All of my denominators in this case, it is here. X cannot be. Negative 5. Here. X cannot be 3. Here. X cannot be 4. And here, x cannot be negative 1. I don't look anywhere else because the original problem was multiplication. Good. All right. Try E at this point. Pause the video, try it on your own, then come back. All right, let's take a look now. Let's see how you did. It's already multiplication, so let's just go ahead and factor. I'm going to have to do this top one off to the side here because it is not a special case, no GCF. I'm just going to have to use my diamond problem and generic rectangle in order to do this one. Some of you might not have looked at 35 and negative 1. Always think of 1 in the original number itself. All right, so 7x. All right, so that all boils down to, let's go ahead and get myself set up here. I've got x plus 7 over 5x minus 1. All right, over 10x, that didn't have to be factored, times 5x over, and this goes down to just x squared, so I know it's going to be just x and x. And what's my diamond problem? Well, that's going to be 7 and negative 3, giving me plus 7 minus 3. And therefore, I can cancel what I see. I've got, let's start with my numbers first, 10 and 5. 5 goes into 5 once, 5 goes into 10 twice. All right, now look at variables. X and x, they cancel each other out. Now look at groups. X plus 7, x plus 7. Look at numbers, look at variables, look at groups. What remains on top is just 5x minus 1 on top. On bottom, careful, I've got this 2 and this x minus 3, and I need to multiply them together, giving me 2x minus 6. And that will be true as long as x does not equal. Let's look at our denominators. So my denominator here, x can't be 0 because 0 times 10 is 0. Here, x can't be negative 7. All right, and here, x can't be positive 3. That's all the places I look because the original problem was multiplication. All right, try F now. Go ahead, try it on your own. Pause the video. All right, continue on with the video at this point. All right, let's look at this. We've got, first off, we have division, so let's change that. We're going to take our first one here. We're keeping the first fraction exactly the same. All right, and then our second fraction, whoops. Our second one here, we're going to flip. Change it to multiplication and change it to a reciprocal. Now let's go ahead and let's factor this out. We're going to go down to a group times a group here. And let's look at the different pieces. I already see this one right here has a GCF, which I'm going to pull out just right above it here. Oops, sorry. I stand corrected. It does not have a GCF. There's nothing in front of that x there. All right, what I meant to say was this one right here. I'm going to pull out and do my generic rectangle and diamond problem. All right, so 2x squared, negative 10, so that gives me negative 20, and it adds to get 1. Well, that's going to be 5 and negative 4. All right, so this goes down to 2x plus 5 over x minus 2. All right, the bottom one here, it is just x squared, so I know it's just x and x. So what multiplies to get negative 8 but adds to get 2? 4 and negative 2, so plus 4 minus 2. X plus 4, there's no GCF there and no x squared, so I'm done factoring that. And this bottom one here might be a little bit of a challenge. You could do all that, but I see this. Notice it is a perfect square trinomial because I can take the square root of 4x squared to get me 2x, and I can take the square root of 25 to get me 5. And the middle is double their product because 5 times 2, if I multiply those, I get 10x. And if I double that, I get 20x, which is what I have in the middle here. So this goes down to 2x plus 5 squared. Now let's cancel what we see. All right, there's no numbers out front, no variables out front. 2x minus 5, and one of these 2x minus 5s will cancel. X minus 2 and x minus 2, x plus 4 and x plus 4. And therefore, I'm left with, remember, these are 1s up top when they cancel, giving me 1 over, on the bottom, I have 2x plus 5. And that will be true as long as x does not equal, let's look at all the denominators, all right, where x is. X can't be, the opposite of plus 4 is negative 4. The opposite of minus 2 is positive 2. Here, the opposite of plus 5 is negative 5, and then the opposite of times 2 is divide by 2, so negative 5 over 2. And I also need to look up top here because the original problem was a division problem. All right, so this x plus 4 was originally in my denominator. And in this case here, I find that x plus 4, I already took care of that, so I'm good. So that would be my final answer there. All right, this takes time and practice, but eventually you will get it. Write down these steps so that you can use them outside of here.